Hello all. So in module 3, we have to learn about arrays and strings. So in this video lecture, I'll be giving an introduction to one-dimensional arrays, then how to declare arrays, how to initialize these arrays, how to access elements in arrays, and we shall see some examples also. Then in the next video lecture, I will give some programming examples also. So first of all, we shall see what is an array. So in the assignment, what you have done, I had given my program to find the mean, median, and mode. So what you did was you declared 5 variables like x1, x2, x3, x4, and x5, and you entered values into those 5 variables, and you calculated the mean, median, and mode of those 5 variables. Now, if you want to find the average marks of a group of 60 students, you have to enter into 60 different variables, x1, x2 up to 60. So it's a difficult task. If you want to calculate the average of 1000 students, then it will be much more difficult. You have to use 1000 different variables. In order to solve that, we require something else. So arrays, it can store a fixed size sequential collection of elements of the same type. So you have to remember this. So arrays can store fixed size. So the size is fixed. And also it's a sequential collection of elements. It's a sequential collection. The first element will come first, then second element, third element. The sequential collection of elements, and it will be of the same type. So if it's an integer type, it can store only integer type of values. If you want to store floating numbers, you have to store in a floating array. So arrays are capable of storing fixed size sequential collection of elements of the same data type. It is used to store collection of data. So it can be considered as a collection of variables of the same type. As in the example I have quoted before, if you want to find the average of 60 students marks of in CPU programming, then you require 60 variables. So if you use array, it can be considered as a collection of those 60 variables together and made into a single variable. So there is another example. If you want to store 100 numbers, so if you do not know array, what you have to do is you have to input values into 100 different variables. Number 0, number 1, number 2, like that, number 99. There will be 100 different variables, and you have to input values into this 100 variables. Instead, if you have an array, you can declare one array variable, and you can give any name to that. Here we have given numbers, so you can declare a single variable, and you can access each element using indexes. So numbers of 0, numbers of 1, numbers of 2, numbers of 3, like that, numbers of 99. So you can declare a single variable like numbers, and you can access the elements, or if you want to store values into those, you can use the indexes. So arrays will be will be storing values using indexes. So specific element in an array can be accessed using an index. So if you want to get the marks of 50th student, so you have to get numbers of 50 or 49, numbers of 49. Since here we are starting with 0 indexing, if you want to get the value of 50th person, the numbers of 49. So it will be like this. So arrays will be like this. So first element will be numbers of 0, then numbers of 1, then numbers of 2, numbers of 3, like that. The last element, if it is a 100 number array, then the last element will be numbers of 99. So arrays consist of contiguous memory location. So this is another important. So arrays are stored in contiguous memory locations, or it is stored in continuous memory locations. So we have already seen that for example, if a compiler or if a system takes, if we use integer type of array, and if a variable takes 4 bytes to store an integer variable, and if you are declaring an array of size 10, integer 10, then 40 bytes of memory will be allocated for that array. Since integer variable takes 4 bytes and we need to store 10 variables, so 40 bytes will be allocated. For example, if the first element is allocated at address location 5000, then the second element will be at 5004, third element will be at 5008, next element will be at 5012, 5016, 5020, like that it will go on. So it will be in contiguous memory location, or it will be in continuous memory location. So 40 bytes will be allocated continuously. That's why arrays consist of contiguous memory locations. So lowest address will correspond to the first element in the array. So 5000 will be the first element. If in the previous case, it will be numbers of 0 will be stored in the 5000 address location. And the last address, highest address will correspond to the last element. So next topic is how to declare arrays. How can we declare arrays? So we have already seen how to declare variables. So it is, we'll simply declare in A, in B, in C, like that we can declare variables. Similarly, we can declare arrays also. For that, we have to use type, we have to give an array name, and we have to specify array size in square brackets, and semicolon will be there. So it is an example for single dimensional array. We will see multi-dimensional array in later sessions. So here we are declaring a one-dimensional array. So here array size. So this array size must be an integer constant. It should be an integer constant greater than 0. It can be any integer constant greater than 0. If we are mentioning it as 10, then we can store 10 values in this array. And type. So here type can be any valid C data type. So we have already seen different data types in C. Int, float, char, double. So it can be any type of data type can be used. And the array name, it will follow the same variable naming rules as we have seen in the variables. Example, double balance of 10. So this is an array and the array name is balance. It is of type double and the size is 10. So we can store 10 elements in this array, or we can store 10 values in this array. Another example, int n of 10. So n is an integer type of array which can store 10 elements. Next is how to initialize these arrays. So in the variables case, we have seen how to initialize these variables when we declare. We used to specify int a equal to 5 or int sum equal to 0. Similarly, we can initialize arrays also when we declare. So this is an example to initialize this balance array. So double, this is of balances of double type with 5 elements, and the 5 elements can be initialized using this braces. So within braces, we can give 5 values separated with commas. So all the values will be separated by commas. So this will be the first element, that is balance of 0. This will be balance of 1. This will be balance of 2. And this will be balance of 3. And this will be balance of 4. So in this way, we can initialize arrays. So we will declare like this, double balance of 5 and equal to, inside braces, we can give 5 different values. So first value, balance of 0 will be 1000, like that it will go on. And another way to initialize without specifying the array size. Here we are not specifying the array size, we are simply keeping brackets. And you can simply give 5 values. So this will be balance of 0, this will be balance of 1 and balance of 2, like that it will go. So both ways we can initialize arrays. Then if you declare it first and if you want to assign these values, you can directly assign using indexes. So balance of 4 equal to 50 means 50 value will be stored in balance of 4. That address location, that value will be assigned to balance of 4. So in this way also you can assign or initialize these values. So this will be the array. Balance 0, 1, 2, 3, 4 and the 54th value will balance of 4 will be 50. So in this way we can initialize arrays. Next is how to access array elements. So if you want to access a particular array element, it is done by indexing the array name. So if you want to get the value of balance of 9, that is the 10th element in the array, you have to use balance of 9 and this value will be assigned to salary. So any values can be accessed using indexing. If you want to get the 5th value, then you have to use balance of 4 and you can assign it to any value, any variable. So we'll see one more example. This is a float array. The name of the array is marks and we can store the maximum size. The array size is 5. So we can store 5 elements. So this will be the array mark of 0, mark of 1, 2, 3, 4. So here arrays have 0 as the first index value. So here you have to remember one thing. When we use C, the first index value will be 0 and the second will be 1. Like that it will go on. So the last value, if the size of an array is n, if the size of the array is n, to access the last element, n minus 1 index should be used. So if its size is 5, then if you want to access the last element, then you have to use 5 minus 1, that is 4. 4 should be used. So this is the example for the contiguous allocation. For example, if the starting address mark of 0, it is in location 2120, and if the compiler uses 4 bytes, then mark of 1 will be at 2124 and this will be at 2128, 2132, like that it will go on. So it will be allocated contiguous memory allocation. So if the first element is at 2120, second element will be at 2124, then third element will be at 2128, then 2132, 2136, like that it will go on. So the address allocation will be contiguous. Then how to initialize an array? So we have already seen, this is another example. Just to understand this, I'm giving another example. In this way we can initialize. This is an integer array. We can simply specify those 4 values in braces. And this is another way without specifying the array size. We have already seen these 2 initializations. So these values will be stored in this contiguous address location. Next, how to change value of array elements. So if you want to change value of array elements, you can simply specify. So this is the array, and if you want to change the value, make the value of the third element. So this is the third element to minus 1. We want to change value of third element to minus 1. So you can simply specify third element means it is mark of 2. So indexing will be second, mark of 2, and you have to assign minus 1 to that. In this way, you can change the values in an array. So if you want to make the value of fifth element to 0, so fifth element is this one. So you have to index 4, mark of 4. So mark of 4 equal to 0. In this way, you can change values inside array elements. Next, how to input values. So if you want to get values from the user, how to get those values? So here also we can use the scanf statement. Scanf. So if you want to take input and store it in the third element, so you can simply scanf %d. So if it is scanf, you have to specify the ampersand symbol to show that it should be stored in some address location. Ampersand mark of 2. If it is third element, so indexing will be mark of 2. So ampersand mark 2 means the third element where some data will be input and that will be stored in mark of 2. So if you want to input and store the ith element, if you want to store something in the ith element, you can specify like ampersand mark of I minus 1. So you can store it in the ith element. So how to output? So we can use the same printf statement to output. So if you want to print the first element of the array, you can simply print %d mark of 0. Mark of 0. So the first element will be printed. If you want to print the third element, you have to input mark of 2. So index will be 2. Then if you want to print ith element, you have to print of mark of I minus 1. So in this way, you can output values. So that's all about arrays. So this is an introduction, and in the next session, I'll show some programming examples. Thank you.